Okay, hi everyone. So now we are going to continue for the third subtopic 5.3, which is a vector product. But before that, let's recap what we have learned before. So you already know how to find the magnitude, which is the formula is, let's say u is your vector. We have u equals to ai plus bj plus ck. To find the magnitude, which is the length, we have square root of a square. Square root of a square plus b square plus c square. Okay, so this is what we call as the magnitude. So that is the formula to find the magnitude. And one more thing we have learned from scalar product, which is to find the unit vector. Okay, which is the formula is, okay, this is what we call as the unit vector. Sometimes we call it as u hat, which is we represent it as u hat here. So the formula is your vector over by the magnitude. Okay, so this is what we call as the unit vector in the direction of u. Okay, we are going to see almost similar thing, the similar thing in vector product. Okay, so here let's go to the note. We are going to cover vector product, which also called as cross product. Why is that? Let's see that later. And we are going to see what is the properties of vector product. And we are going to see how to find the area of parallelogram and triangle and what is the relationship with vector product. So here we have the definition of vector product. We call this as A cross B. That's why we call vector product as the cross product. So the formula is A cross B equals to magnitude of A, magnitude of B, sine theta, and this is what we call as the unit vector. Okay, but this part here is unit vector perpendicular. So the keyword here is perpendicular to A and B. Okay, remember the keyword here is perpendicular. So what we have learned from scalar is just unit vector in the direction of u. But for this vector product here, we have a unit vector that is perpendicular to A and B. And we represent that as n hat. Okay, so as you can see from the diagram here, let's say this is the direction of A, vector A, and this is the direction of vector B. If we cross this by using right hand rule, which I'm not going to explain that, you are going to get this here, a normal here, which is a normal that can be a positive value and also negative. Okay, so can be positive or can be negative. That means if we cross A and B, we can get positive normal and negative normal. Okay, so that depends on what direction by using the right hand rule. Okay, so here we have a unit vector normal or perpendicular to both A and B. So the keyword is perpendicular. So now if we have let's see here, if A and B are parallel vectors, okay, if we have A and we have B is parallel, this is what we call as parallel, which is the degree, the angle is 0. So by using this formula here, you'll get sine 0, which is sine 0 is equals to 0. So that's why we get A cross B is equals to 0. Okay, if you remember, let's recap. If we have, okay, let's not use that. Okay, if we have A dot B is equals to 0 for your scalar vector, for your scalar product, A dot B is equals to 0 is when A perpendicular to B. Okay, that is one thing. But for vector product, if your A cross B is equals to 0, that means A is parallel to B. Okay, so these are the two things that you have to remember. These two the properties that very important. Okay, very important properties. One is from scalar product or dot product, and one is from cross product. Okay, A dot B equals to 0, A is perpendicular to B, A cross B equals to 0, A is parallel to B. So you can see from here, if I cross I, you'll get J, J cross J, you'll get K, K cross K equals to 0. Okay, and if A and B are perpendicular vectors, then that means theta here is equals to 90 degree, which is, you know that your sine 90 degree is equals to 1, and then we end up with this formula here to find the unit vector perpendicular to both A and B. If you remember your formula for unit vector before, from the scalar, we have U, the vector, divided by the magnitude. Almost the same thing, but the difference here is your U, your vector here, is A cross B. So you have to find the A cross B first, okay, as your U. Okay, so this is unit vector in the direction of U. This is the unit vector perpendicular to both A and B. Okay, alright, so let's see how to find the A cross B, how to find the cross product here. So these are the definition here. So let's do this. This is the definition. We have A cross B, and you can see the determinant there. So you know how to find the determinant. You already know from the matrices. So here is going to be plus, minus, plus. Okay, so what we are going to do is we are going to just to top this part. We are going to close the first part, the I column, and then we have A2 B3 minus A3 B2. Okay, is AD minus BC. Okay, the same thing, the same method as finding the determinant. So that is plus there, and then we are going to close the second part, which is the part J here, and we take A1 B3 AD minus BC. Okay, A3 B1 J. So, and the last part here, we close this part here, we have A1 B2 minus A2 B1. Okay, so that is how we find the vector product, okay, or the cross product. As you can remember, if we, from the checklist, let's see the summary here. If we do this, A dot B, we get a value. Okay, if we do this, A1 B1 plus A2 B3 A3 B3, if you do your dot product, you'll get a value. Okay, but if you do your cross product, you'll get a vector. Okay, dot product, we get a value. Okay, a constant. Cross product, we get a vector. Okay, so now let's see example 16. Given A and B, find A cross B. So we are going to find A cross B. So write A cross B. Make sure your vector has to do the wave there, the ombak there. Okay, so let's write I, J, K here, and here we have 2, 3, negative 2. Okay, from here 2, 3, negative 2 for your A, and for your B 4, negative 2, 3. Okay, so that is the determinant. Now we are going to find the cross product. The first part, tutup. Okay, we are going to close this one here. Padam. Tutup je lah this one here. Okay, so we are going to take 3 times 3, which is we have 9, minus negative 2, negative 2. Okay, so negative 2, negative 2, we have plus 4. So plus 4 here will be minus 4. Okay, so remember the formula is AD minus BC. Okay, start with positive. Positive minus positive. Okay, plus minus plus. Okay, so here the second part here, so here is your I. Okay, because you close your I here. So we are going to close the J column here. We are going to take the same thing, AD minus BC. So AD is 6, BC is minus 8. So 6 minus negative 8. So there we have plus 8. Okay, make sure you be careful here. Negative 8. Okay, so here we have minus, and the last one we have plus. Close this part, the K row here, we have AD negative 4 minus BC, which is 12. So we have negative 4 minus 12K. And this one here we have J. So make sure you calculate properly, and then we should have 5I minus 14J minus 16K. So as easy as that. Okay, just the same method to find the determinant. That is how you find your cross product. Okay, so now let's see example 17. Given A and B, find A cross B. So let's do it one more time. We have A cross B. equals to, here we have I, J, K. Our A is 1, 2, 3. B is negative 1, 3, negative 1. Okay, so let's find the cross product. Close I, we have 2 times negative 1, 3 times 3. Okay, remember, plus minus plus. Okay, so 2 times negative 1, we have negative 2 minus 9 I. And we are going to close this part here. 1 times negative 1, we have negative 1. 3 times negative 1, we have negative 3. So here we have minus negative 3. Okay, make sure you be careful, extra careful with the negative. Okay, so here will be J plus. And the last one here, we have to close this part here, we have 3 minus negative 2. Okay, so we have 3 minus negative 2, which is 3 plus 2k. Okay, we are going to simplify that. We should have negative 11i minus 2j. We have negative 1 plus 4. Negative 2j plus 5k. Okay, for question B, here we have proof that A cross B is a vector. So here we have A cross B as one vector, which is perpendicular. So the keyword here is perpendicular to the vector A. Okay, so what we have to do here is we have to show that A cross B as one vector perpendicular to vector A. So that is what we have to show. So what you know from one vector perpendicular to one vector? We have, let's say we have A cross B, sorry, A perpendicular to B. What do we know from here? We mentioned this earlier. A perpendicular to B, that means we have to show that A dot B equals to 0. Okay, so we have to show that A dot B equals to 0. So for our case here, we have to show that A cross B is perpendicular to A. That means we have to show that A cross B dot A is equals to 0. So that is what we have to show. So let's take A cross B, which is this part here, negative 11 minus 2 plus 5. Okay, so here we have, let me write one more time, A cross B dot A is equals to, A cross B here we have negative 11 minus 2, 5 dot A. A is this one here, 1, 2, 3. 1, 2, 3. Okay, so let's do the dot product from here. Make sure you get a value. Remember, dot product will get a value. So here we have 11 minus 4 plus 15. Okay, 11 minus 4 plus 15, which is, this one is negative 11. Negative 11 minus 4 plus 15, which is, we'll get 0. So we can conclude that A cross B is perpendicular to A. Okay, is perpendicular to vector A, since A cross B dot A is equals to 0. Okay, so that is one way to show the perpendicular vector. So here we have the properties of vector product. Okay, there are few properties, but the most important properties here is what we have done earlier. Okay, that A cross B equals to 0 if A is parallel to B. Okay, from here, A perpendicular to B, A dot B equals to 0. But if A parallel to B, A cross B equals to 0. Okay, and here as you can see, A cross B is equals to negative B cross A. So kamu akan dapat jawapan negatif lah kalau kita terbalikkan dia. So you cannot terbalikkan dia. Tak boleh B di atas, A dekat bawah. Okay, if the question said A cross B, A dekat atas, B di bawah. You cannot simply put B, A here. Okay, if B, A, that means you should put B cross A. Okay, because the answer will be negative. Okay, so let's see example 8. If A, B and C find A cross B. So this is like the normal thing that we do from before. You can do this by yourself. You should get 7i minus 7j minus 7k. Okay, so let's see this example here. We have A cross B cross C. Okay, so A cross B is from this question A here. So just take, we want to find A cross B cross C. So A cross B you'll get from the first example here, A cross B, which is we have 7I minus 7J minus 7K. We have to cross by C, which is C you have negative I plus J 3J minus 2K. Okay, so that's what we have to do, but we don't have to write this, just put in the cross form, in the determinant form. So we should have IJK, your A cross B is 7, negative 7, negative 7, and our C is negative 1, 3, negative 2. Okay, and then do as what we did earlier. You should get the answer 35I plus 21J plus 14K. Okay.